look into pattern recognition. And what we've done is we've given them very basic shapes like circles, squares, triangles, and crosses, and they also have to identify them. After that, we have asked them to coordinate the hand-to-eye movement because there is a lack of depth. And so some patients, for instance, some of the volunteers use their hands as feedback regarding the sizes and the distances. So we gave them certain cards with the same object printed in different sizes, and they had to classify them according to the size. And finally, we gave them small text sequences. It had numbers and letters, and they had to order them accordingly to a sequence. After that, and since I would like to talk to you now about multi-resolution analysis and why it's important. We capture the image, color image, and the first thing that we do is we transform it into a scales of grays, and then there are different resolutions. We have low resolutions and high resolutions that we have applied in order to have different characteristics of the image. The parameters that we have, and in the experiments that we have done, the volunteers were able to see how wide the filters are, so how wide they are. We work with different filter widths in each electrode in order to obtain information around that electrode. After obtaining information about the electrode, we get the phosphene map, which is a map of the shape of the dots of light in order to get the simulated image. Just to get an idea of how it works, let's say that this is the image. If this is the coordinate of one of the electrodes, then the regions that are being analyzed increase, and the patient is able to change the area that is being analyzed. So, for instance, in the sky that doesn't have so much information, we can get a wider area. And we can also adapt the phosphenic image. We were not able to bring here the system that is being developed because it's currently being tested in Sydney, but I brought some examples of what would be the reconstruction of simple images that we showed during the studies. So an image such as this would be perceived like this. But it's also interesting sometimes for the subject to obtain more information about the shape and the silhouette of the image. So we are studying whether we can use high frequency analysis in the image and if they are of interest for the patient. I would like to also say that the volunteers that participated have evolved as well. At the beginning, they found it really hard to adapt to the new vision because the angle of vision is very limited. But as we were increasing the amount of sessions, they were faster in carrying out the tasks. Also, all subjects were able to read, to find or identify the spots of light, to identify movement, and they were also able to read small words, bringing the sequence closer to the camera, because there are different kinds of resolutions, different kinds of space between the phosphenes, the dots of light. And they were able to coordinate their hand movement to help them, to help their sight. Also, we saw that given that the resolution could change, we found that the low resolution analysis was more useful than the high resolution analysis. It gave them an image similar to what they had before. However, in some of the tasks, such for instance identifying sizes, the use of high-frequency techniques gave them a greater idea of the shape, and it was easier for them in that case to identify shapes and patterns. So it has been demonstrated in some studies, not many, that it is possible to identify spots of light through electric through electrical stimulation. So the first studies will combine 98 electrodes or phosphanes. Given that the resolution is small, we need to have algorithms that are able to extract the most useful features of the image and to show them in such a manner to the blind person that are useful for that person. We have used multi-resolution algorithms because they make it easier to adapt to the person, and this is some bibliography in case you are interested. And thank you very much for your attention.
Muchas gracias, Alejandro. Sí, ahora entre los participantes.
Thank you very much. Alejandro, I don't know if there are any questions. My name is Alvaro. I come from the Granada University. First of all, I would like to thank you because I thought that your presentation was extremely interesting. It's fascinating. But I also wanted to ask you something about, first of all, the resolution. I imagine that there is financial limit, but maybe in the future, where you mentioned those 98 phosphanes, maybe that could be increased in the future. Also, you said that you've only used one camera. But would it be possible to use two cameras and give some kind of stereoscopic vision, even if it's only with lights? And finally, and this is more philosophical,